All right, so today we're going to talk about function notation and something called domain and range. So, in domain and range, I'm just warning you, people kind of don't like them. They're a little abstract to kind of wrap your mind around. But I'm gonna do my best to try to explain it for you guys today. So, all right. So yesterday, um, we had the activity with the box and the Skittles, and I wouldn't worry about writing this down. You can just pay attention to this while I'm going over it here. Um, at least this part right here. The other parts I want you to write down. But you remember how yesterday we had our box and then we had all the Skittles of different colors. And then if you put in a 1, it gave you like a red Skittle. If you put in a 2, it gave you a green. I think it was actually purple yesterday, but whatever. This works fine. The colors don't matter that much. But anyway, so you have what's called a mapping here. So this over here is called a mapping. And what it does is it shows you, hey, if you put a 1 into the machine, you're going to get a green Skittle. If you put a 3 into the machine, you're going to get an orange Skittle. If you put a 6 into the machine, you'll get a yellow Skittle. A 7 also gets you a yellow Skittle, so on and so forth, right? So this relation right here, which we're looking at the mapping of it right here. Again, the mapping takes the inputs here and sends it to the outputs. So this relation here, this happens to be a function. As well as a relation. So it's a function because every input has a very predictable output. You never guess what output you're going to get. Like if I put in 1, I know I'm getting a green Skittle. That's weird. According to the table, I get a red Skittle, but according to the mapping, I get a green Skittle. Anyway, those are supposed to match. But so what I want to do now is move this over to some numbers, okay? So let's look at example 2 here, okay? And I'm going to give you a table, and I'm just going to give you some outputs here. And I want you to try to guess what the pattern is. In other words, how do I get from the number on the left to the number on the right, okay? So on the left, we've got 1. 1 goes to 4. So if you put in 1, the output is 4. If you put in 2, the output is 7. If you put in 3, the output is 10. If you put in 4, the output's 13. And then 5 gives you 16. And then 18, I guess we're jumping down to 18. That gives you an output of 55. So what we're saying here is if you put in a 1, then you do something to the 1, and then you get 4. So like some people are like, oh, well, the pattern or the rule is to add 3. And it's like, okay, cool. All right, let's try that. So if we add 3, so that works for the first one. If we add 3, does that work for the second one? And the answer is obviously no, right? Like 2 plus 3 is 5, not 7. So your goal here is to try to figure out what the pattern is to go from the number on the left to the number on the right. And you'll notice the number on the rights are growing pretty quickly, right? Like 4, 7, 10, 13, 16. These are only going up by 1 here, right? So these are going up 1 every time. So that's kind of nice. But these are going up by 3 every time, it looks like, right? 7 to 10 is plus 3. 10 to 13 is plus 3. So what's happening here is there's definitely, because you can tell the ones on the right are going up by 3 instead of going up by 1 every time, there's definitely some multiplication going on here. So, and here's a nice little trick. I'm just going to give you a little trick here. When this goes up by 3 every time, that 3 number actually kind of indicates to you what you're multiplying by, which makes sense, right? Like if you're going to add 1 here and then this is going to go up 3, then this is kind of going up 3 times faster than this is going up over here. So instantly, I actually already know that the pattern's going to be, you're going to take the input and multiply it by 3. So I'm going to write 3x. That's not the whole pattern. People are like, Mr. T, really? You think 1 times 3 is 4? Like, okay. But usually what happens on problems like these is you multiply by something and then you add or subtract after you multiply. So if we multiply by 3, that would get us 1 would turn into 3, 2 would turn into 6, 3 would turn into 9, 4 would turn into 12, 5 would turn into 15, 18 would turn into 54. Okay, so when you multiply by 3, it gets you now to the yellow number. And now the question is, how do we get from the yellow number over to the green number over here. So how do we get from 3 to 4, 6 to 7, 9 to 10, 12 to 13? Well, that's actually pretty easy. You just add 1, right? Okay, so what we're going to do then is we're going to say the pattern here must be multiply by 3 and then add 1. And let's check and make sure that works. It's got to work for all of them. It can't just work for a couple of them. So if we multiply by 3 and then add 1, so 1 times 3 plus 1 would give you 4, so that works. 2 times 3 would give you 6 plus 1, that gives you 7. 3 times 3 plus 1 gives you 10. So, and you can keep going down here, but I can promise you it works for all of them. Not plus, times. 5 times 3 plus 1 give you 16. Okay, so that's your pattern there. So the pattern here is take the input number, multiply it by 3, and then after you multiply by 3, you add 1, and that would give you the output number. And that works for all of these. So this is a really crucial, important skill. And if you're good at doing this, especially with live statistical data, like for insurance companies, you can make a lot of money. Okay, next one. All right, here are your outputs. You ready? So go ahead and put these for your outputs. So 1 maps to -2, 2 maps to 0, 3 maps to 2, 4 maps to 4, 5 maps to 6, and 12 maps to 20. Okay, so typically what I like to do on these is kind of look at the pattern over on the right. The pattern on the left is still, we're just going up by 1 every time. So that makes life a lot easier when this goes up by 1 every time. What about on the right, though? It looks to me like we're going adding 2 here, then adding 2, then adding 2. So it looks like we're adding 2 every time. So I'm going to assume we're probably going to multiply by 2. Multiply the input by 2, and then we just kind of have to ask ourselves, like, all right, if you multiply the input by 2, what do you have to do to it after that? So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. So how do I get from the number highlighted in yellow here over to these guys on the right here? So what's the pattern to get from the yellow over to the green here? So how do I get from 2 to -2? How do I get from 4 to 0? How do I get from 6 to 2? How do I get from 8 to 4? Looks to me, I think that we're subtracting by 4, right? So if you do 2 minus 4, that gives you -2. 4 minus 4 gives you 0. So I'm just doing these right here. 6 minus 2 gives you, 6 minus 4 gives you 2, so that works. And then 8 minus 4 gives you 4. Yeah, so it looks like the pattern here is that we're multiplying our input by 2 and then subtracting 4 on it. Okay? So multiply the input by 2, subtract 4. How do we say that? So 2x and then minus 4. That would give us the pattern here. Okay? All right, let's move on to the next page here. So I know these notes are like super, super long, but they're not, they don't take that much time to get through. Okay, so I want you guys to think of a function as a machine that takes inputs, processes them, like does something with them, and then creates an output. Okay, so like yesterday, when we put a 1 into the machine, we got a red skittle out. When we put a 2 into the machine, we got a green skittle out, right? So that was the output. So the machine did something to the 1, and then all of a sudden it said, hey, like you should return a green skittle. Okay, and then when you put a 3 in, it turned orange skittle. Okay, so that right there is a function as far as we've seen so far, right? Whenever you put in a number, you get a very predictable outcome. And instead of a number, you get a skittle, a color skittle. So functions are kind of cool. They can take anything as an input, and they can provide anything as an output. It doesn't just have to be numbers, right? It could be colors. It could be letters. It could be, like YouTube. Have you ever heard of a YouTube algorithm, right? Like YouTube algorithms take the kind of video that you watch, and then they provide more content that you might like. Netflix does that too. Netflix has a lot of function algorithms built into the computer program. Okay, so in general, here's how a function works. So what you do is you take your input, you put it in, and then we usually just put the name of our function right here. and then it provides an output. So that's how functions generally tend to work. And they usually are written like this. So we usually use x to denote the input number that's going into the function. We typically call functions f, although you might see g or h sometimes or some other random letter. But f is kind of the default name for a function. We just like that. I think it's because function starts with f. And then the output, we usually use the letter y to represent the output number. Okay? So, and then we got to talk about something very important here called function notation. Okay, so function notation is a very specific way of writing the pattern or rule of a function. And it's very similar to the way we use symbols to express the relation yesterday. So here's an example of something written in function notation. So this right here is called function notation, and I want to point out some important aspects of it. Okay, so the name of the function is that first letter. So the name of the function is that f right there, okay? And then the input goes right here. So this is the input of the function. So x, in this case, is the input of the function. And then this little thing right here, this 2x plus 1, this is the output of the function, okay? The output of the function. And more than that, it's actually, this is also, can't spell today, this is also the rule that shows how to get from the input to the output, that shows how to get from the input to the output. So you can call it the output, but within this 2x plus 1 here, it's actually showing you what you need to do to the input to get the output. Okay, and this is a really, really profound idea here, and if you get this, like you're gonna do really well in algebra. Okay, and then there's a really important note here. So when we write f of this, we say f of x here. We call that f of x. That's how we say that out loud. The f and the x are not multiplying each other. This is really important. People think, oh, I'm supposed to multiply the f and the x. No, no, no. F is, this is called function notation. So we say it's f of x. So what we're doing is we're declaring, hey, there's a machine here, and the name of the machine is f. And what it does is it takes inputs, which it calls x, and then feeds them through the machine, and then the output at the end is called y. Okay, so you'll see, you might see like f of x equals 2x plus 1 or something like that, or you might see y equals 2x plus 1. They're saying the same thing, right? Because the y here is the output. It's what you get when you run f through the machine. So this right here is called f of x, and it's saying, hey, take the x, whatever the x is, a number, a letter, a color, or something like that, feed it through the machine, and the machine will tell you what to do with it. Okay, like in this case, what's the machine saying? It's saying double it and then add 1, right? 2 times x plus 1. So double the input and add 1. So that's a pretty basic function, right? Double it and add 1. That's not too crazy. Some of these YouTube algorithms would like blow your mind if you actually understood how they work. Okay, so let me give you some examples of functions, okay? So h of x, we would say h of x equals 3x minus 1. Okay, that's this function. So we say h of x because h is the name of the function and x is the input on the function. And in order to get an output, the function h takes numbers, which it calls x, and looks like it multiplies them by 3 and then subtracts 1. Okay, so that's a function right there. G of x equals 2x. So g is a function. So the name of the function is g. It takes inputs, which it calls x, and then what does it do to its inputs here? Like if you look at the rule here, so it says 2x here, so it's doubling the inputs there. Okay, so my Apple Pencil decided to stop working, so we'll see how this goes. Okay, what does so let's look at this function right here. So this function is called d. That's the name of the function, d. It takes inputs, which it calls t, and what does it do to its inputs? So d takes inputs, which it calls t. It looks like it subtracts 1 from them and then takes that result and then divides that by 2. Okay, so x isn't always the input. It's usually the input for stuff we do, but sometimes you might see other letters. So don't feel too uncomfortable. Just pretend like the t's are x's. So this is kind of the same thing as saying d of x is equal to x minus 1 over 2. Okay, how about this one? So this function is called m. So that's the name of the function. And what does m do? So m takes inputs, which it calls black box. I don't know what to call that, like black square. So it takes things and it calls them black squares. And what it does is look at the rule over here. It takes the black square and then it adds 5 to it. And then it looks like after that, it doubles the result. Okay? So it adds 5 inside the parentheses there, and then it doubles the result. So it multiplies that result by 2. So that's what that function does. Okay? So let's go ahead and look at the next page. Okay? So here's a question for you. What do you need to be able to write a function using function notation? Okay? And this was just given above over there. So you need the name of the function, which is usually f, but not always. The name of the function. You need a symbol, and this is usually a letter, and it's usually x. Usually a letter, usually x. Not always, but usually. To represent the input, And then you need an expression to show the rule. Of the function. And when I say rule, so you need an expression to show the rule of the function. When I say rule, I mean what needs to be done to the input to get to the output. What needs to be done to the input to get to the output. So those are the 3 things that you need for a function. You got to know what the name of the function is, what we're going to call the function. You got to have a symbol that you're using to represent the input, because you don't know what the inputs are, but you have to give them a name in order to feed them through. And then you need an expression that's just going to tell you how to get from the input to the output, like what the rule is there. Okay? Okay, so example 4 wants us to create a function that takes an input number x, doubles it, and adds 1. So here's our function. So we have our function here. So we're going to take x. F is the name of the function. So it takes inputs, which it calls x. That's right there. And what does it do? It doubles it and adds 1. So we could put a y here, but instead of y, let's put 2x plus 1, because this right here really captures the idea of what the function's doing. It's taking this number, it's doubling it, and then it's adding 1 to that result. Okay, so this is it. That's all they want you to do. Okay, so how do we write this in function notation? We say f of x, that's how we say that, f of x is equal to 2x plus 1. Okay, that's it. That's all you have to do for that. Okay, how about example 5? So create a function g that takes an input number x, adds, okay, so let's do that. X, the name of the function is g. It adds 3, then divides that result by 2. So it's going to take the input, it's going to add 3 to it, and then it's going to divide that entire result by 2. Okay, so our function notation would be g of x. So this is the name of the function. This is the input right there. Equals, so how do we get the output? You take the input, you add 3 to it, and then you subtract 2. So that's the rule here on this one. So that's your expression that gives you the rule of the function. Okay? All right. How about example 6? Create a function m. So m is the name of the function that takes an input number n, multiplies the input by itself, then adds 7. Okay, so how do we multiply an input number by itself? We say n squared, so n times n, or you could also put n times n if you want. That would work, but I'm just going to write n squared, and then it adds 7 to the result. Okay, so a function notation here would be the name of the function m, the input of the function n is equal to n squared plus 7. Okay? So that would be your function notation. All right, next page. Create a function f that takes an input number x. Okay, so here's f. That's the name of our function, input number x, doubles it, and then adds 5. So what would that look like? That would be you double the input, so 2 times the x, and then you add 5 to the end of that there. So you would say f of x equals 2x plus 5. Okay? Okay, and then the last thing we're going to talk about today is domain and range. So sometimes, just reading off the notes here, sometimes it's helpful to talk about all the inputs that could possibly go into a function and all the outputs that could possibly come out of a function. So if you think about our machine yesterday, what were all the inputs that we put into our machine? So like if you go back and you look at our inputs over here, if you had all the inputs listed out, what would they be? So it was just all the cards that were on the table. So you could have put in 1, 2, 3, 4, 5, 6, 7, or 8. Those were the possible inputs you could have put in. You couldn't put in a 9 because I didn't have a card out there that had a 9 on it, okay? So this is a list right here of all the potential inputs for that function from yesterday. And then what were the outputs? Well, the outputs were just the colors of the Skittles. So it was a red Skittle, it was a green Skittle, it was an orange Skittle, it was a yellow Skittle, and then it was a purple Skittle. And these are all Skittles. And just for the sake of time, we're just going to say these were all Skittles, right? Okay? I just don't want to write Skittles out 5 times. Okay, so here's your definition. You ready? So the name that we give this list right here, this list of all the possible inputs that you could put into a function, we call that the domain. Okay, so if you list out every possible input you could put into a function, that's called the domain. Okay, and for algebra, we're usually going to deal with numbers, right? Like we're usually interested in numbers. There are a lot of applications where the inputs are like rap music or something like that. Like on Spotify, right? If you have or Pandora or something like that, if you have a streaming app for music and you like rap music, that's going to be an input in that function. And then the algorithm's going to be like, okay, if you like rap, you might also like this kind of music, or you might like this kind of artist or something like that. Okay. So, or, if you like country or, whatever. Okay. So the list of all the inputs is called the domain. The list of all the outputs of a function, like this list over here, that's called the range. Okay? So the domain is the list of all the inputs, and the range is the list of all the outputs. Okay? So last example here, I think. So we're going to consider the function f of x is equal to 2x minus 1. So pretty simple function. The domain for this function is limited to the following numbers. Okay, so it's saying, hey, we're only going to plug in 1, 2, 3, 4, 5, 6. Okay, obviously you can plug in more numbers into this function, right? Because if you're just doubling something and subtracting 1, there's a lot of options there. But we're going to limit that to 1, 2, 3, 4, 5, 6. And then the outputs here, we're supposed to figure these out. So let's do these real quick. So if the function says double the input and then subtract 1, what should we do here? So if you double the input, so you get 2, and subtract 1, you get 1. If you double this and subtract 1, you get 3. If you double this and subtract 1, you get 5. And then 7, 9, and 11. Okay? So the domain on this function, they already gave it to us. The domain is we are just going to list these numbers out. Oh gosh, that was a terrible bracket there. So the domain is 1, 2, 3, 4, 5, 6. And then the range here is going to be 1, 3. So I'm just going to list out all the outputs here, right? So these are the outputs. So I'm just literally writing them out. 1, 3, 5, 7, 9, 11. And that's it. So the range is just the list of all the outputs if you wrote them all out. And the domain is the list of all the inputs if you write those all in. Okay? All right. Well, that's it for today.